In this video, we're going to go over the properties of rectangles, rhombi, and squares. So we're going to start off with our rectangles. And so a rectangle is a quadrilateral with 4 right angles. It follows that since both pairs of opposite angles are going to be congruent, a rectangle is a special type of parallelogram. Thus, a rectangle will have all of the properties of a parallelogram. However, a rectangle has additional properties, and that is going to be that your diagonals are going to be congruent. All right, moving on to our rhombi. A rhombus is a quadrilateral with 4 congruent sides. Since opposite sides of the rhombus are going to be congruent, a rhombus is a parallelogram and is going to have all of the properties of a parallelogram. The diagonals of a rhombus have 2 special relationships. Okay, so the first one's going to be that the diagonals are perpendicular to each other. And then the second is that each diagonal bisects the 2 angles of the rhombus. Okay, now we're going to move into where we are going to determine the difference between whether it's a rhombus or a rectangle. So, is the parallelogram a rhombus or a rectangle? You must first determine if that quadrilateral is a parallelogram. Okay, so that's going to be key. Then you can use one of the following theorems to determine if it is also a rhombus or a rectangle. Okay, so the first one for our rhombus is going to be consecutive sides are congruent. The second one is one diagonal is going to bisect 2 angles. And then the third way is if the diagonals are going to be perpendicular. So those are the 3 ways for my rhombus. Moving into my rectangle here, we have if you can prove the diagonals are congruent. And lastly, we have adjacent sides are going to be perpendicular to each other. That's what's going to form that right angle that we mentioned as part of my definition of the rectangle earlier. All right, and then in our final section here, we are going to talk about squares. So a square is a quadrilateral with 4 right angles, so it's a rectangle, and 4 congruent sides, so a rhombus. So therefore, it has all of the properties of a parallelogram, a rectangle, and a rhombus. Also, to show that a quadrilateral is a square, you need to show that it is a parallelogram, a rhombus, and a rectangle. All right, so for the next few problems, we are told to use the rhombus PQRS and the given information to find each value. Okay, so let's start off with the first part of it. We have if SQ is 24. Right, so I'm going to label from S all the way to Q is 24. And we know that PR is 10. we are asked to find SR. Okay, so we're asked to find this length here, which, if you remember, think back to our properties of our rhombus. We have that our diagonals are perpendicular. So we know this is a right angle. We have a little right triangle being formed right here that we can use to find that length. Because remember, if you have a right triangle, you can always use Pythagorean theorem to solve for a missing side length, which we only have one side length missing. Okay, so remember, the diagonals are going to bisect each other on a parallelogram, and a rhombus is just a special type of parallelogram. So what we know here is, I can look off to the side over here, that my right triangle is going to have two lengths. We've got 10 divided by 2 will give me 5. And that 24 divided by 2 will give me 12. So I have two lengths. I know that one side is 5, one side is going to be 12. And so I can use that Pythagorean theorem to solve for my missing hypotenuse. All right, so we'll get 5 squared plus 12 squared is equal to c squared. So 5 squared is going to give me 25, plus 12 gives me 144. Sorry, 12 squared. So when I add those two together, I'm going to get 169 is equal to that c squared. And so when I take the square root, I'm going to be left with that SR is equal to 13. Okay, so we now know that SR is 13. Moving into our next problem here, we are asked to find the measure of angle QRS given that angle PRS. So let me highlight this to see which angle that is. We've got PRS. This angle here is going to be 17 degrees. Okay, so if I'm looking for QRS, QRS is going to be the entire angle. And so if we remember, the diagonal is going to bisect that angle. And so I can double it to find the whole angle. So I'm going to say 17 times 2 is going to give me 34. So the measure of angle QRS is 34 degrees. Okay, then we're asked to find the measure of angle STR. So starting at S, I go to T, and then to R, which is forming that right angle that I had already drawn in here from earlier. Okay, and just a reminder, diagonals are perpendicular to each other on a rhombus. So that's where I'm getting the measure of angle STR is equal to 90 degrees. All right, our last and final one for this picture here we have is if SP. So SP is going to be this length here is 4x minus 3. And PQ is 18 plus x. We want to find the value of x. Well, remember, on a rhombus, another property is going to be that all of my sides are going to be congruent. So those two are going to be equal to each other. And so I can use that to solve for my x. Now, something to just mention real quick. While yes, they do all use the same picture, we don't necessarily know that they are building off of each other. They could be just using the same picture and that's it. So we are going to play it safe by just setting that 4x minus 3 equal to 18 plus x instead of trying to use that 13 we found earlier. All right, so I'm going to solve this by subtracting my x from both sides. I'll get 3x minus 3 equals to 18. Then I'm going to add that 3 to the other side. I'll get 3x equals to 21. And when you divide by 3, you'll be left with x is equal to 7. All right, so moving into the next set of problems, we have used the rectangle RECT and the information given to find each value. So starting off with this one here, we are given that the measure of angle RCT, that's going to be this angle down in the corner, is 30 degrees. And we want to find the measure of angle ETC. All right, so looking at a few properties that we know that the diagonals are going to bisect each other, as well as the fact that the diagonals are congruent on a rectangle, and so therefore all 4 of these parts are going to be congruent to each other. So if I look at what I have, if I focus on my triangle that is being formed by those diagonals of ACT, I will notice that I have 2 congruent sides, which means I'm going to have 2 congruent angles. It's an isosceles triangle. And therefore, the measure of angle ETC is equal to 30 degrees. Okay, so moving into number 6, we have if RC is 5x plus 2, so this entire length here is 5x plus 2, and we know that A to E is x plus 14, I'm asked to find the value of x. So I already kind of covered this, but remember your diagonals are congruent, okay? And the diagonals do bisect each other. So what I can say is that 5x plus 2 that I'm given is going to be equal to 2 times AE, that x plus 14. Okay, so solving this, I'm going to distribute, and I'm going to get that 5x plus 2 is equal to 2x plus 28. I'm going to subtract that 2x from both sides, and I'll get 3x plus 2 equals to 28. Subtracting 2 from that is going to leave me with 3x is equal to 26, and therefore when you divide, you'll be left with x is equal to 26 thirds. All right, so moving into our last and final problem for this section, we are given that the measure of angle EAC is 40 degrees, okay? And we are trying to find the measure of angle AEC, that's going to be this angle here that I'm marking. Well, some things to keep in mind. Well, going back into what we talked about with number 5, remember this is going to be an isosceles triangle here because we have the diagonals are congruent, and then them being bisected as well is going to split them up into congruent segments. And so we'll have this isosceles triangle here that we can use to find the missing angle. Now, keep in mind there is that 30 degrees there. We don't quite know that it is using the same angle measure from number 5, so we want to stay away from using that. But we can use the fact that the sum of my angles in a triangle is going to be 180. So I can subtract the 40 that I do currently know from that to get 140. And then I'm going to take that 140 that's left over and divide it by 2, since I have 2 angles left. And you're going to be left with the measure of angle AEC is equal to 70 degrees. All right, so now we're going to move into the back side. And these problems are slightly different. Okay, so I'll read it and then I'll zoom in. But we have determined whether it is a parallelogram, rectangle, rhombus, or a square for each set of vertices. State yes or no for each and explain why or why not. Show work to support the explanations. Okay, so looking at number 8 here, okay, I want to just kind of mention this for all of these, that the order in which I am listing it off here, MNOP, is also the name of it. And so we don't necessarily have to plot them to figure out exactly the order. We can just use that as the order. And so I'm going to start off by first just drawing a picture. I'm going to do this down below just because I know this is the section I'm going to have room for it. And I'm just going to draw it as a parallelogram, calling it MNOP. And just for the sake of me having to scroll down, I'm going to go ahead and write the coordinates for them as well so I don't lose them. Okay, so I'm giving myself a visual that I can use to determine a lot of different things, but also to help me kind of explain what I'm doing. So remember, one of the key things with a parallelogram is going to be the fact that by the definition, your opposite sides, both pairs of opposite sides, should be parallel to each other. Okay, so I want to prove, if this is a parallelogram, that M to P is parallel to NO, and that MN is parallel to PO. So that's what I'm going to start off by doing. So we have MN So finding the slope of that, we would find the difference of my y coordinates. So 5 minus 5. And then the difference of my x coordinates, so 6 minus 1. I'm going to get 0 over 5. And so that slope is going to be a 0 slope. Okay, so I want to make sure that the other side is going to be the same. So we'll have PO So for PO, I'm going to do 10 minus 10, and then that's 6 minus 1 again, which will give me that 0 over 5, which will just be a 0 slope. So far we have one pair of opposite sides. Let's check to see if the other pair is parallel as well. So we have MP, which will be 10 minus 5, and then 1 minus 1. This here is going to give me 5 over 0, which is going to be an undefined slope. And then lastly, we have our NO. So 10 minus 5, and then 6 minus 6. Once again, will give me that 5 over 0, which is just an undefined slope. Once again. All right, so that will answer if this is a parallelogram. Okay, so we have yes. And then we want to explain why, which would just be that both pairs of opposite sides are parallel. Okay, remember we do need to mention is both pairs of them that we are finding to be parallel. All right, moving into our rectangle, this actually will answer my rectangle as well. Because remember, for a rectangle to have that right angle, you have your consecutive sides will need to be perpendicular. So if we look here, we have that zero slope, that undefined. Those are perpendicular to each other. And so my answer is yes. We can just say consecutive sides are perpendicular. Okay. Moving into my rhombus, there's a few ways you can do this. I'm going to stick with my slope, okay? And so using my slope formula, I am going to determine are my two diagonals going to be perpendicular. So I'm going to find the slope of MO, which will be 10 minus 5, 6 minus 1, 10 minus 5 is going to give me 5 over 5, which will just give me 1. And then find the slope of the other diagonal in P. So 10 minus 5, 1 minus 6. Get that 5 over negative 5 this time, which is just going to be a negative 1 slope. And so those two slopes are perpendicular. So we can say, yes, this is a rhombus. And my reason to justify it is the diagonals are perpendicular. All right, and there is no more work needed for the square. For my square, we can just say, yes, it is a rectangle and a rhombus. All right, so that's how you can solve problems like number 8. We're going to do this 3 more times, okay? And for some of them, I will kind of switch it up on how I go about doing it. But it's just you finding whichever method you want to use, whatever property you want to prove to work through it. All right, so starting off, once again, I am going to, just because I'm going to have to scroll down and everything, draw just a quick illustration. We've got W, X, Y, Z. I'm going to write my coordinates in with them. All right. So another way to determine if it's a parallelogram is, remember, we can determine, do the diagonals bisect each other? Okay, so I'm going to find the midpoint of my two diagonals. So we'll start off with diagonal WY. We'll have 5 plus 0 divided by 2, and then 4 plus that negative 10 divided by 2. All right, so when I simplify, 5 plus 0 gives me 5. I'm going to just have that 5 over 2. And then 4 plus negative 10 is going to give me negative 6. Divided by that 2 gives me negative 3. Okay, and then moving into my other diagonal, we've got x, z. So 3 plus 2 divided by 2, negative 6 plus 0 divided by 2. 3 plus 2 gives me 5. So I'm going to have that 5 halves again. And then that negative 6 plus 0 leaves me with a negative 6 divided by 2 gives me negative 3. Okay, so based off what we've just determined, we can say, yes, this is a parallelogram because the diagonals bisect each other. Okay, then moving into our rectangle. Okay, so for the rectangle, we've talked about how you can find the consecutive sides slopes and determine if they are perpendicular. Another way is to determine if your diagonals are going to be congruent. Okay, so I'm going to then just find the lengths for my diagonals that I had to see if they are congruent. All right, so plugging into my distance formula, we have the square root of, we can do 5 minus 0 squared plus, and then we'll have 4 minus negative 10 gives me just plus 10. Okay, so then going through and simplifying, we've got that 5 minus 0, 5 squared, plus we'll have 4 plus 10 gives me 14 squared. So we'll get 25 plus 196. And then just adding those together, we'll get the square root of 221. Okay, and so then trying to just simplify, we've got some factors are going to be 13 and 17, which both of those are prime. And so therefore, my answer is just going to be the square root of 221. Now let's check and see if we get the same thing for the other diagonal xz. Okay, so taking the square root, we'll have that 2 minus 3 squared plus, and then we'll have 0 minus negative 6, so 0 plus 6 squared. Okay, so 2 minus 3 gives me negative 1 squared plus that 6 squared, which leaves me with 1 plus 36. So we'll get that we're getting the square root of 37. Okay, well, since these two here are not the same, they are not equal, we know that this is not going to be a rectangle. So my answer is no. And we can say the diagonals are not congruent. Okay, so now let's move into our rhombus. Okay, and so for our rhombus, we could use the distance formula once again. It is slightly long, so I'm going to go ahead and I've done it once. We might do it again later. But I'm going to go into what we had done in the previous one by just checking the slopes of my diagonals here and determining if they are perpendicular. Okay, so let's look at the slope for the diagonal WY. So we have 4 minus negative 10, so plus 10. And then we'll have that 5 minus 0. So this is going to give me 14 over 5 for that slope. And then we've got xz, we can do 0 minus negative 6 gives me 0 plus 6. And then we have that 2 minus 3. So we'll get 6 over negative 1, which is going to give me a negative 6 slope. And so these two slopes here are not perpendicular, and therefore it is not a rhombus. So diagonals are not perpendicular. And once again, remember, this will answer, once you've worked out all three of those, this will give you your answer for your square. And so my answer is no, not a rectangle or rhombus. All right. Now let's move into number 10. Doing the same thing. So starting off, I'm going to draw once again, just a quick visual in case I need to move down to where I can't see it. We have D at 1, 10, E at negative 4, 0, F is at 7, 2, and then G is at 12, 12. All right, so you have a few options of how you want to prove it's a parallelogram. I'm going to go back into doing the midpoint once again. So I'm going to find the midpoint of DF. I've got 1 plus 7 divided by 2, and then 10 plus 2 divided by 2. So 1 plus 7 is going to give me 8, divided by 2 gives me 4. And then 10 plus 2 gives me 12, divided by 2 gives me 6. So then looking at GE, we have 12 minus 4 divided by 2, and then 12 plus 0 divided by 2. So 12 minus 4 gives me 8, divided by 2 gives me 4. And then we've got that 12 divided by 2 to give me 6. So once again, this is a parallelogram because the diagonals bisected each other. Okay, so now let's see if this is going to be a rectangle. All right, so to determine if it's a rectangle this time around, I'm going to go ahead and just determine, are my consecutive sides perpendicular? Okay, so I'm going to find the slope starting off of DE. So 10 minus 0, and then 1 minus negative 4 gives me plus 4. So we'll get 10 over 5, which will just reduce to 2. Okay, and then we have the other side, DG, that we're going to find the slope of. So we've got 12 minus 10, and then 12 minus 1. 12 minus 10 is going to give you 2. And then 12 minus 1 is going to give me 11. Okay, so looking at those two slopes here, we know that this is not going to be a rectangle because the consecutive sides are not perpendicular. These two slopes are not perpendicular to each other. Okay, now moving into my rhombus. So for my rhombus, I'll go ahead and go back into that distance formula of just determining if my consecutive sides are going to be congruent. Okay, so we'll use the same two consecutive sides. We're going to do DE to begin with. So 1 minus that negative 4 gives me 1 plus 4 squared. Plus, then we'll have 10 minus 0 squared. So reducing, we're going to get that 5 squared plus 10 squared. Okay, and I'm going to erase a little bit of this. Don't need it. And then we can square them to get 25 plus 100 is where we get the square root of 125. Okay, for the sake of practicing simplifying our radicals, we've got some factors of this could be 25 and 5. Well, that 25 is a perfect square, so we've got 5. Root 5 is going to be the length of DE. So now let's check DG. Okay, so for DG, we will have 1 minus 12 squared plus, then we'll have 10 minus 12 squared. So 1 minus 12 is going to give me negative 11 squared plus, then we'll have 10 minus 12 gives me negative 2 squared. And so when we square them, we're going to get 121 plus 4. So once again, that is going to give me 125. So I already know what my factors can be to simplify this. And so therefore, the length of DG is going to be at 5 root 5. And so we can say that this is going to be a rhombus. Okay, so my answer is yes. Consecutive sides are congruent. Okay, so once again, we have our answer for square. Since we know this is not a rectangle, we know this cannot be a square, so no, and we can say not a rectangle. All right, now let's look at the last and final problem for these notes. We have number 11, starting off once again by just drawing a quick visual, just so this helps me personally make sure that I know exactly which sides are going to be opposite and which sides are going to be consecutive, what my diagonals are, all of that. All right, so now that we have this, we can determine starting off if this is a parallelogram. I'm going to go back into my slopes like I did in the first one. So I'm going to start by finding the slope of RE. Okay, so my slope for RE will have 6 minus 5, and then 5 minus 7. So 6 minus 5 is going to give me 1 over, and then that 5 minus 7 gives me negative 2. So we're going to get a slope of negative 1/2. Then checking, we've got TS. We can do 10 minus 9, and then 7 minus 9. So we're going to get 1 over negative 2 again. So we've got one pair of opposite sides to be parallel to each other. Now let's check the other pair. So we have RT. So 10 minus 6, and then 7 minus 5. We're going to get 4 over 2, which will just reduce to 2. And then for ES, we'll have 9 minus 5, and then 9 minus 7, which is going to give me 4 over 2 again. So I get a slope of 2. So my answer is yes, this is a parallelogram. Okay, remember, both pairs of opposite sides are parallel. Okay, then we have a rectangle. Well, based off what we just showed, we actually are answering both questions. This is a rectangle, yes, because if we look at the consecutive sides, we've got that, for example, RE and then RT. So these two here, you'll notice we have a slope of negative 1/2 and a slope of 2. They are perpendicular to each other, so yes. And my answer is just consecutive sides are perpendicular. All right, then for my rhombus, this one we will need to work out some more. We can find the slope once again. So of my diagonals, we've got RS. So we can do 9 minus 6, and then 9 minus 5. So 9 minus 6 is going to give me 3. 9 minus 5 is going to give me 4. So we'll have a slope of 3/4. Then comparing it to the slope of the other diagonal, ET, we've got 10 minus 5, and then 7 minus 7. So 10 minus 5 gives me 5. 7 minus 7 gives me 0. Well, 5 over 0 is just going to be an undefined slope. And so these two slopes are not perpendicular, so therefore this is not going to be a rhombus. Which gives me my answer for if this is a square or not, which it is not, because it is not a rhombus. All right, so that is it for our lesson over rectangles, rhombi, and squares. The one thing I do want to end this off with is in these examples back on the back side, notice how that for my reasoning, every single time it matched my work, make sure that whatever reasoning you are coming up with is one, going to be identifying kind of a theorem that we know for those properties, but two is going to relate to the work that you are showing. Okay. If you are showing me slope, I should not see as a reason that the sides were congruent. Okay. Because you didn't show me distance formula, you showed me slope. It should match up to the reason I am using to justify on whether or not it is a parallelogram, rectangle, rhombus, or square. All right, so that is it for this lesson.